In this video, I want to talk about the mechanism of action of beta-lactam antibiotics. Why they're all grouped together is because they have a beta-lactam ring, so this four-membered ring structure. Who belongs to the beta-lactam antibiotics? The penicillins, the cephalosporins, the monobactams, there's only one representative, which is aztreonam, and the carbapenems. The beta-lactam ring is responsible for the mechanism of action. And as you probably know, the beta-lactam antibiotics are cell wall synthesis inhibitors. And in order to understand their mechanism of action, we first need to look at cell wall synthesis. How is a cell wall made? And then we can see which step the beta-lactam antibiotics interfere with. You probably know that most of the bacteria fall into two categories, being either gram-positive or gram-negative. The gram stain reflects the bacteria's cell wall. So gram-positive bacteria have a very thick cell wall and therefore can hold on to the stain that you're adding, which is violet, purplish, blue. And in contrast, the gram-negative bacteria, which have a thinner cell wall, cannot hold on to it. And therefore, you're going to stain it with a counterstain. And this counterstain is red. So let's look at the cell wall. The cell wall of both gram-positive and gram-negative bacteria contains peptidoglycans. So first of all, there are glycans. So these are sugar molecules, which I'm drawing here. But obviously, this is not very stable. So we need to somehow hook them up to give the cell wall some rigidity. And so peptide chains, which I'm drawing now, are basically hooking up the different sugar molecule, the glycosaminoglycans. And therefore, we call the major constituent of the cell wall peptidoglycan. And this is a cell wall. Gram-negative bacteria have the exact same peptidoglycan cell wall. This is just a little bit thinner, so there's less layers. Both gram-positive and gram-negative bacteria have a cell membrane which harbors the organelles, and the gram-negative bacteria have, in huge contrast to the gram-positive bacteria, a outer membrane, which is a lipid bilayer. So let's look a little bit more in detail how bacteria make this peptidoglycan layer, and then also see how the beta-lactam antibiotics inhibit this synthesis. The sugar backbone is made out of two alternating sugars, N-acetylglucosamine and N-acetylmuramic acid, which are abbreviated as NAG and NAMs. And then we obviously need these peptides that hook up the different sugar molecules to give the cell wall some rigidity. And these are 5 amino acids that are added onto the NAG. And then there's a pentaglycyl unit, which is connecting the one strand with the other. I've also listed here the names of the different amino acids that are used. Now, an enzyme that facilitates this hooking up is called the transpeptidase. And that's exactly the enzyme that is inhibited by every beta-lactam antibiotic. So it turns out that the D-ala ending looks a little bit like the beta-lactam ring, and therefore the transpeptidase cannot tell the difference. It will also bind on our beta-lactam antibiotics, and therefore this enzyme will be inhibited. This concludes the video on the mechanism of action of beta-lactam antibiotics.